So first of all, very good evening to all of you guys, and welcome to one of the unique uh, motivational or rather unique activity which we started called Tech Confab. This is a cloud series one that clearly says that this is going to be a continuous series, right? So based on your feedback, based on the outcome, based on the request, we will even try to have these series in a continuous manner, right? So the current series is based on OpenStack, is basically a private cloud, right? So we all know there is a AWS, Google, or Azure. These are as in as a public cloud. But why OpenStack? What is the logic behind OpenStack? That we will be discussing in this Tech Confab Cloud Series 1. Uh, my name is Ashutosh Bhakare. I welcome you all. I welcome all of you for this event. With me, I have my colleague called. His name is Pavan. Pavan Wankade. We all know him. So let's have a quick introduction. So before that, let's set up the expectations and the agenda of this 4 hour series, right? So we will talk about cloud, what is cloud, why you need cloud, types of cloud, different types of cloud scenarios, OpenStack, what is OpenStack, why you need OpenStack, the use cases of OpenStack, that also we will discuss here. Then we'll talk about some component level or architectural level discussion on OpenStack. That is, which what are the components like Nova, Neutron, Swift, what they do, those things we'll discuss, and architecture also. So today's agenda is still architecture of OpenStack. Tomorrow we will have a hands-on demo on OpenStack, how you can use OpenStack, how you can deploy your own private cloud in OpenStack, right? So let me introduce myself. Will request Pavan to introduce himself as well. So my name is, as you know, Ashutosh Bhakare. I am a corporate trainer and a consultant last 22 years. I'm a Red Hat certified instructor, Google certified instructor, SUSE certified instructor. Uh, Recently did or have been selected as a AWS community builder. They AWS name it as a CB, community builder, under which uh, I am supposed to spread of AWS and upskill myself also. So yeah, this is my short intro. I request Pavan to introduce himself quickly.
Thank you so much, sir, for blessing up the agenda very much clearly. We are getting echo, sir, your end. Not sure why.
Maybe because of my mic. You can go ahead.
Okay, thank you. So, yes, thank you for setting up the agenda and giving your introduction quick and nicely, as usual. So, guys, let me clear one thing that in the agenda we are having. Let me clear it one more time. That is, we are having a four hours agenda. Today we'll go for 2 hours, and tomorrow 2 hours. Okay, don't get panic like we have suddenly joined, or maybe we misplaced with something. Maybe it's clear that today 2 hours and tomorrow 2 hours. Out of which tomorrow 2 hours will be mostly towards the demonstration with the hands-on. Now, I just want to give a quick introduction of mine. My name is Pavan Satish Wankade. You can call me Pavan. I'm consultant as well as corporate trainer. I deliver different types of tools and technologies to different corporate. It's like from Linux administration, then virtualization, then cloud, OpenStack, uh, in like Ansible, Puppet, Chef, then in containerization, mostly towards Podman, Docker, in orchestration tools with Kubernetes, OpenShift. OpenShift. So these are my fields. Along with that, I usually provide consulting and training for DevOps as well. Whatever names I have just now taken, right? So using those plus add on to Git, Jenkins, these kind of tools, how can someone implement DevOps solutions, and if someone is already having DevOps solution, how to make it run, how to keep on it running, and how to upscale it. So these are the things we usually deliver. Along with this, I do have two instructor titles with me. I'm Red Hat certified instructor as well as SUSE certified instructor, and I'm a community leader for Indian open source community. And as a part of job, I am working at Unnati Development and Training Center Private Limited as a CIO. Okay, so this is like a quick intro to me. Now I just want to say one more thing. Just enjoy this discussion of cloud. Okay, you might be already aware about what is cloud, and if not, still you're always all all of us are users of cloud or cloud services anyhow. So this is going to be very interesting session. So let's start with all about the cloud. I think Ashutosh sir, if you place the next slide, and if you convey that what is there on that slide, that will be better. I just want to request you for that.
Yes, Pavan. So great. I think let's slide, Pavan. Then you can take probably the next slide or next discussion ahead. Uh, Regarding the cloud, you know exactly the cloud is. If you see the cloud logic, Pavan, you can mute yourself just to avoid the echo. Yeah. In the cloud, if you see what exactly the cloud is or what exactly the logic is, right? Cloud is nothing but a infrastructure not available locally. That's it. So I remember when I was a kid, uh, I used to buy a or what you can say PlayStation on rent, right? That was basically a blue color box, and there was a cassette which used to have a rent of 5 rupees or 10 rupees per hour, something like that. Even cycles, that was the era where cycle was getting on rent. Right? The same thing is happening today also. If you see Yulo bike in Bangalore or Pune or Mumbai, it's basically e-bike which is getting on rent. So people had the same thing again. And I believe history repeat itself. History actually repeat itself. Whatever you get today may get older, but day after tomorrow you will get it again. That is what is happening in an OpenStack itself. And I still remember that there was a era where was around 40,000. See, I am talking about right 18, 20 years back story when I say 40,000. 40,000 is 40,000 at time. So I believe now you can say 3 lakhs or 2 lakhs. You can compare it because now 40,000 is that you're carrying 30,000 mobile in your pocket. That's different stuff, right? But at that time, when hardware was too much expensive, people was renting. People was taking the desktop on rent, maybe per rupees per month, 1,500 rupees like that. Why? Because they don't afford the hardware cost. Same thing happens in a public cloud itself, like AWS or Google or maybe Azure or Microsoft. What happens is the enterprise, the organization, the companies, the clients are basically buying or taking the hardware on rent. Simple. This comes with lot of limitations, right? Lot of limitations when I say public cloud. That's why we have an excellent product, OpenStack. Just to set up a context, just to give you a value of OpenStack, OpenStack is built by NASA and Rackspace together. NASA and Rackspace, you might not knowing Rackspace, that's okay. But if you're knowing NASA, we all know NASA, right? NASA has developed this in collaboration with. Now you can imagine why they develop. We will see why they develop. But whether it is a private cloud, whether it is a public cloud, they all fall under one vertical the diagram. That vertical is nothing but infrastructure as a service. IaaS. I'm repeating my statement, whether it is a public cloud or it is a private cloud, it falls under a simple category called IaaS, infrastructure as a service. Happens in this vertical is what happens in this logical scenario is, as name suggests, you get infra. You get infra. It's like, imagine a case that you have to make a sandwich at home, right? Will you start making a bread also in home? What do? You go and buy the sandwich. You buy a sandwich directly, right? Bread, right? You go to a bakery shop and you will say, boss, please give me a fresh bread, right? What he will say, okay, 3 दिवसाचा bread दिला, and this is a no problem. And bread path of okay, that is okay, fine. Jokes apart. So the bread is what? Infra. You take a bread and put your tomato, put your whatever you want, paneer or whatever, and then make it. Then you may need a toaster or heater or whatever, or sandwich maker, whatever. Here is, no one is going to make a bread from in home, right? Same happens in the pizza also. Imagine a case that you want to make a pizza at home. You have an oven also. You will not start making the dough, that base. You will go and buy the base. That base, it's available nowadays. Shop, it is available, correct? Right? I hope online people can hear me loud and clear.
Yes,
Just
sir.
to take a pulse of a class. Nice. So basically, it's rather difficult to make a base. At home, no one can make a base. You can make a base, that's not an issue. Just to give you a logical stuff is, Domino's and Pizza Huts are famous. You know why? They don't buy base from the bakery. They make their own base. I am not sure how many of you have ever seen it. If you go to Domino's, you go to Pizza Hut, you will see that they are making a base for it. Now, there is a difference between Domino's and Pizza Hut also. That's okay. That's it. But the point is infra. Right? So, because to make an infra, it needs a lot of efforts. Now, I need to deploy one application. I need to one application. The first thing comes in my mind is, I need a computer. I need a hardware. I don't have anything. I will go to shop. I will buy a hardware. Buying is okay. Then I will install the operating system. Then I will plug it. And the moment I plugged it, I will come to know that, oh, there is a load shedding happening for 4 hours. Today is Friday. There is a maintenance activity. What will you do? You have to put a UPS. Then you have to put a network, put an internet. And then you will come to know that the internet service provider which you are using is not working. Some people had cut the net. Then what you will do? You will buy another backup internet, second internet. What if that happens same with the second internet also? So setting up activity is really, really painful. Right? So what happens in infrastructure as a service is, whether it is a private cloud or whether it is a get these much things, which backup, UPS, internet, network, hardware, you get everything available. After that, what you need to do? You need to install your software. You need to maintain your application. That's it. That's what is shown here. In the red block, if you see, managed by vendor here, you will get a virtualization, servers, storage, and networking. How you will get? This is provided by your vendor. Now, our vendor is maybe public cloud or private cloud. Then what you manage once you got a hardware. Now here, let's try to understand. When I say managed by vendor, I'm considering the vendor. We all are vendors. Okay, and our client is someone else. Our customer is someone else. So that is managed by you is not we. Our customer. We will deploy OpenStack. We will deploy AWS. Who will use it? Client will use that blue box. That blue blocks has to be managed by your clients. What he will manage? OS, middleware, runtime, data application, all this tag will be managed by your end user or customer. That is what is known as infrastructure as a service. Very, very simple. Make sense? Now, let's come to platform as a service. PaaS. It is also form as a service. Now, I have taken an example of sandwich. Right? Imagine a case that you open a Swiggy application in your mobile. You select a sandwich, 1 plus 2, whatever. Okay, 30 minutes, 40 minutes, sandwich is at your home. Once a sandwich reaches, what you will do? Eat. You need a table, you need a soda, or you need a water, or tea, whatever, snacks, whatever. So, another point is after eating, you have to clean the table also. You have to throw the items also which are not required, whatever. Correct, na? Katha's table also. You can't do that, right? So that is platform as a service. In that, your efforts are less. Data and application will be managed by your client. Rest of the thing by we. Upon vendor है ना, we. What we will manage? Runtime, OS, everything. Like a Kubernetes, like a OpenShift. These are platform as a service. Right now, third option. Third option is really simple. Go to restaurant, order the sandwich, have it, come home. That's it. Painless. Of course, you have to give money or you have to spend money. That is, of course, needed. This is known as software as a service. Everything who manage, we manage. What customer will manage? No. He will say, I need my application up, and that is software as a service. Getting the point? It's very, very simple. And you take any example. Why I'm taking this eating example, it will be relative. Na? Gulab jamun. How you make a gulab jamun? Nowadays, you get readily available gulab jamun. Lot of options, same thing. Because efforts are minimized. Now, first, see, I'm not discussing, I'm not even discussing. Why? Because that people are not using nowadays. That's where platform is gone. It needs a less effort deployment, less painful deployment. See, another logic is it's not, I'm not saying it's bad also nowadays, but there are some cases like in private cloud, you need this. But in private cloud also, what you do is, are you managing the entire stack? No. Even let's talk about some credit card company like Visa or MasterCard or whatever. They have their own private cloud team which manage that red blocks, and they have other team which manage that blue box. That is infrastructure as a service. So in this today 2 hour and tomorrow 2 hours discussion, we will talk about infrastructure as a service. I hope it is very much clear. Any doubt, anything you want to ask, anything you want to add, Pavan?
No, sir. All good. I'll take the next slide then.
Great. So the next is, of course, types of cloud. Over to you, Pavan.
Thank you so much, sir. Will it be okay if I share screen from my side?
Yes.
Okay. Just a minute. So can you confirm, is it visible from your end, your projector?
Yes, Pavan.
Okay, thank you so much. So yes, guys, with a good discussion, healthy discussion about what is meant by infrastructure as a code or platform as a service. After that, I just want to add few more points to this. That is, in infra, when you try to think about infrastructure as a service, so it's like providing everything by your own. Suppose I am the provider, so I will provide everything. Or suppose you and me, okay, two people, we have started one our own organization for IT infrastructures. So what we can do is we can rent out one hall. In that one hall we can set up our own physical devices, power backup, internet backup, and everything. And then on top of that we are going to apply some kind of services, storage service, computing service, virtual machines, okay, number of other things as well, like let's say networking services. All of these things we are going to host out there. And after hosting and making that entire infrastructure ready, if we are going to use that for our organization only, then this concept is called it as the private cloud. If you can see here, there are four clouds here, like public cloud, private cloud, community cloud, and hybrid cloud. Out of those, public and private we have to understand first. So I hope I'm clear with my topic. I'll repeat again that what is meant by private cloud. Suppose you and me together, we are hosting one organization, we have enrolled one organization, we are starting our own venture, own company. And we have rented out one space, or maybe we are having one building with us, and there we are having 50, 60 servers with us. We have our own data center, you can say, where internet backup, power backup, everything is there. And on top of that, we are hosting some services, any kind of services. If someone wants to run, means if someone wants to run the container, we have service for that. If someone wants to perform some kind of application development, we might have services for that. Someone wants a ticketing tool, we do have a service for that as well. Someone wants to use any virtual machine for 10 days of some XYZ configuration. So we have that kind of facility as well. Someone wants to just store some data as files on our infrastructure or on our facility. That is also there. So lot of services are there, and we are not renting it out to anyone. We are only using it for our organization itself. This is called it as a private cloud, where I am using or I am hosting everything within my campus, or within not only the campus, but it is there under my ownership, under our ownership, organizational ownership. And those services we are using in house. Yeah, obviously whatever applications we are going to host, whatever applications we are going to deploy, these may be accessible, or these may or may not be accessible outside the network, outside the internet. Anyone can use it, but those are hosted inside my campus, where I do have a assurity that my data is not leaving my campus. This statement is very important, where I'll be rightly sure that the data is not get saved or transferred outside. Yeah, obviously with applications or with some services it might be useful to get access outside, but it is not going to leave my campus. So this kind of security we are having, this kind of implementations if we do, then these services we call it as a private cloud. Now at the same time, you can think about it that our cloud is ready and we are using it for in-house purposes. That is okay, but we have spent a lot of amount to build such kind of functionalities, such kind of infra. And whatever services we have hosted on top of that, those services, if we rent out to someone, if we rent it out to someone, then we might get good earning as well. Forget about means let's keep, not don't forget, but let's keep the earning side aside. If we say that if I am going to have these services, I will make those services open for some group of people, and they can give me some kind of rewards. Rewards is like maybe client for my some other services, maybe in some format they are going to pay to me, maybe they are going to make my advertising of some kind of products. By such means, I'm going to offer my services to we get access for outside people. Means look towards this. You and me are the owner of this, right? Suppose you are having your friend and he is a good developer and he wants to host web services. So what we can do is we can rent our web hosting services to him. Suppose one of your friend is very good with hosting the web servers, not only the development of the pages and hosting the website, but managing multiple web servers. One of your friend is very what we can say interested about it, and he's kind of professional into that. But what happened, he don't have budget, or maybe he is not having the IT skills, or he really don't want to invest into the infrastructure more. In such cases, we can rent out our services to that person also. So if we are earning something, or we are renting it out, or we are maybe allowing someone else to use our services, but the infrastructure is still in our campus and we are allowing other people to use it, this is called it as a public cloud. I can give you best example for this. You all are using somehow, some way, some kind of public cloud. You might have heard about Amazon Web Services, Google Cloud Platform, Microsoft Azure platform, cloud platform, right? These are very famous names, right? These are all public clouds. What you have to do, you have to give your account or account information or credit card, debit card information, and they will allow you user account. Through that user account, you're accessing their services. You really do not have accurate idea that where actually they are hosting everything. Where is the physical infra? You're just getting one login in the browser through internet, and then you're using their services. Yeah, obviously you're selecting the region and all. What is that region and all, will come to that discussion. But this is the way you're just creating the account and you're accessing their hosting. This is what we called it as a public cloud. So who needs private clouds and who need public cloud, by the way? So it's up to you what you would want. Suppose, just like as like Ashutosh sir says, rightly says, that is, if you want to bake your own bread, then do it by your own way, and then make the sandwich also from that, and then sell it that, or eat for yourself, or have it by yourself. But at the same time, it is also possible that someone is going to bake the bread for you and they are going to offer that bread to you. You can have your sandwich over there then. An ultimate option is bring you can buy, or you can bought the so we can you can buy the entire sandwich itself. So it's up to you, no? So what happened is, like, if I want to build everything by my own for some security reasons, I do have enough money for that, I do have enough time for that, I do have enough technical people around me with that, I do have internet backup, I do have area, I do have land, I do have everything, then it is okay. And then it is also a good solution that you should have your private cloud. But if you really don't want to spend the time, efforts, money, and everything into that, but you're okay to host your services on someone else's cloud, then the best option is public cloud. It's like, I want to go from Mumbai to Hyderabad or Mumbai to Pune, suppose for example. It's not necessary that I should buy my own bus or own car, right? If I buy, that is okay. I can go and buy my own car. I'll buy a new car and then I'll go to Pune. That is good. But at the same time, if you want to go for Pune for once or twice only, it's not a daily job for you. In that case, why to have your own car for that? You can rent it out. You can travel in a public bus also if needed. So that's the requirement. And there are two more clouds in the picture you can see here: community cloud and hybrid cloud. Okay, so community cloud and hybrid cloud, especially talking about the hybrid clouds, what happened in hybrid cloud is, it is a combination of public and private. Now you might wonder why we need this. Many organizations want few of the services hosted at the rooted level on their campus, where some data, some services should not leave their campus, and that is a very old solution also, maybe legacy infra they are having maybe. And at the same time they also want their few services to be get hosted on some private cloud. Okay, there might be different reasons for that. One of the reason can be, let's say, if my infra if my public cloud is having some issue and some connectivity problem for a couple of minutes or maybe for a couple of days, in that case at least essential services should run on my private cloud. There should not be everything down. Or there can be other reasons also. Sometimes I cannot offer all the services of the private all the services of the public cloud. It is going to be that is going to bill higher, because if I want to travel for a complete 3 years daily daily from Mumbai to Pune, then I should not spend my money on the cab, right? It is better I should buy my car. So if that is the situation, in that case you need to think on that. If you're going to use public cloud and they are going to bill you a lot for whatever your usage is, maybe you're using that for a long time, then it's better that initial plan supposed to be you should build your own private cloud and use it. But there are few services which you can host on public cloud, but many of those services you should have in your private cloud. Then there is a concept that you should have a combination of services like this, and that's what we called it as a hybrid cloud. And then there is community cloud also. I think community cloud, we should not discuss more about community cloud right away, because that might be confusing or stretch the discussion too much. But it's something like community cloud, right? So communities can host cloud services, and respective community members can access those services. This is kind of a relevant concept of it. But let's talk about community cloud some other day. Now, when we are talking about this, there might be a question in a beginner's mind that few minutes back you were talking about OpenStack and now suddenly about cloud. What is this? So basic idea is, if you want to build your own cloud service, then you have a best solution for that, and that is called it as a OpenStack. I hope this relation between OpenStack and cloud is clear to all. If someone wants to build their cloud, then OpenStack is one of the software stack, you can say, with the help of which you can build your cloud. So online people, can I get a quick confirmation in the chat box? Is this clear with everyone that what is meant by public cloud, private cloud, and what's the relation of that with OpenStack? If yes, we can, within 2 minutes I'll discuss about what is OpenStack and its history. 2 to 3 minutes max. Perfect. So what is this OpenStack? Okay, the in short, Ashutosh sir has given the idea about OpenStack's history. So let me tell you one thing. OpenStack, just split that word, open stack. So it is basically a stack of different services together. I'll repeat, it is the stack of different services together. If you separate the services inside OpenStack, no, you will understand that there are independent services, and if you group them together under one head, that one head we called it as a OpenStack. Means, if you want virtual machines, then for having that we do have a separate service. If you want to have object based server, object based storage, object store we call it, then for that we do have separate component. If you want to have identity, see, lot of services will be there, then definitely multiple users will use that. If multiple users are going to use that in different ways, so it's better to have a mechanism where identity and what we can say authentication and authorization supposed to be done. For that also we do have a separate component for that. So these are independent services and we collect them together, and that is what we called it as a OpenStack. So OpenStack was initially created during the first months of 2010. Can you imagine that? Cloud is not that new. Okay, you can see within 2010, Rackspace wanted to write an infrastructure as a code running its cloud servers offering. As they want to build their own infrastructure as a code thing. At the same time, parallelly, you can say um, NASA was also trying to do similar activities or similar kind of things for their projects. You might have heard about the NASA's Nebula project and some relevant projects in that 2008, 9, and 10, in that era. So that time, NASA has come up with solution of publishing these things with the help of some service called Nova. Nova name service they have initiated, and then Rackspace and NASA came together and they have finded out a good solution, that this can be a good computing solution to have your virtualization solution. Virtualization was there at some time, but if you want to have your on demand computing, if you want to have your on demand computing consists of memory, CPU, and essential root disk. Okay, so if that we club, that is what the computing solution is. So computing solution on demand, they have made it available with Python based code. Remember, Python based code. So this entire OpenStack project, majority of the components got written in Python. Okay, so initial components are completely written in Python. Later on, some other languages are also came into as a contribution. But somewhere in 2010, it got started. After that, slowly, few more organization had started coming up there. Somewhere in the nearly at the end of the 2010, huge organization has understood this part, that is they got convinced, they got impressed with this, and huge organization in technology domain has started showing interest to this. And that was the point from where officially OpenStack started their releases. Here I do have a Wikipedia link. I'll quickly show you what is there in that link. See here, we have intentionally chosen Wikipedia, so anyone can have a look to that after this, after these 2 hours. When we are talking about OpenStack, no, in OpenStack, see, original author is Rackspace and NASA, Rackspace and NASA. So they had this open initial infrastructure for this. When they are having open initial infrastructure, maybe the text is not readable to you. Let me try to increase the font size if needed. Ashutosh sir, is it readable?
Yes, it is readable.
Okay, thank you. So I was talking about, like, initially it was owned by, initially it got started by Rackspace and NASA, but they are not the owner of the product. Okay, initially they have started it. Later on, developers have started joining that venture. So basically, they have started this community, and using that community, that this product has grown. Now, if you see, it got started from then, but now till today, we are having nearly 25 versions of OpenStack available in market. It's one after another. First release, second, third release. Likewise, we are having 25 major releases in market for this. 25. Can you imagine that? After every 6 months, within, see, it got started somewhere in 2010. This is 2023. Okay, so within these 13 years, they have released, means this OpenStack community has released more than 25 versions. So approximately, also, if you calculate, no, 6 to 9 months time span is there. Within that time span, they usually release the next version. So if someone asks what is the release cycle of OpenStack, we can say that 6 to 9 months. 6 to 9 months release cycle is there for OpenStack every release. So if you see the history also, no, I just want to show you quickly, and then I'll hand over this to Ashutosh sir. See, this was the first release. Its name was Austin. It is in alphabetical order. Okay, it's like A B C D. You can say. First release was Austin. Okay, it was released in 21st October 2010, which was having two components, means two services. You can say Nova and Swift. We are going to discuss what are these services in very much detail within few minutes. So Austin was the first release. After that, we got one more release, that is Bexir. It was having three components: Nova, Glance, and Swift. Later on in 2011, Nova, Glance, and Swift got lot of lot of what we can say facilities got added into that. Now, up to that 2011 2012, it started growing. It became famous. Somewhere here in 2011, somewhere here with this 2011, this particular version, I hope you have heard about one organization named SUSE. I hope many of you are aware about this, right? SUSE has started their own product in the market called SUSE OpenStack. That time the name was a bit different, but nowadays we call it as like SUSE OpenStack. They have started their own distribution with OpenStack. You can say like Linux was there, then Red Hat, Debian, everyone started their own Linux distributions, right? Similar to that, OpenStack Enterprise releases, these organizations started distributing. Before this version, everything was only for community purposes. But now,
Just to cut through,
yes,
these are the upstream versions. What Pavan is telling us, these all are upstream versions. When
correct,
he says SUSE, that is basically a version, right? So till Diblo, most of the upstream or open source version is used. Later on, SUSE and Red Hat and then Mirantis came into picture. These are downstream.
correct,
Good.
correct. This was the version S6, right? This was the version on which Red Hat has started their first distribution. Okay, first downstream of Red Hat OpenStack. Red Hat OpenStack has started with this particular version. And you know what? I think you are aware about this. IBM is having a great wing into their what we can say under their head, that is Red Hat, and Red Hat is having very excellent product in market, that is Red Hat OpenStack, and they have started here somewhere in 2012. Slowly, what happened, more innovation happened to this cloud world, and these components got added. If you see, the latest version we are having today is Yoga. Nearly 1 year back, we had this particular version, Yoga. Now how many services are there? 38. Means more than 40 services were there. Few services got merged with each other, and few services got stopped their development. So that's why somehow the total is nearly 38 services now. So I think this is the point where we should understand that it's a great innovation product available in market. So every technical person, every IT person should have knowledge of OpenStack, and that is the motto of this particular event also. Also, if you see, go to OpenStack website, no, you will be able to see lot of use cases as well. So if you go there, you will be able to see that there are different industries: banking sector, research sector, finance sector, mobile sector, technology related companies, then let's say telecom industries. You know what? In Asia, let's talk about India. I think Ashutosh sir will agree with my point. 100% telecom industries in India are using OpenStack. Am I
Yeah.
correct, Ashutosh sir?
You can even say APAC, not on in only
No,
India.
yes, yes, yes.
Yes,
I was
yes, yes.
about to say
I
that.
was about to say
See,
that.
in the entire
In
APAC
the
region,
entire impact, we
100% of the
100%
telecom
of the
industries
telecom
are
industry
using
are
OpenStack.
using
This
OpenStack.
whichever mobile phone you're
Whichever
using, the
mobile
whichever
phone you're
mobile
using,
network,
whichever mobile
that
network, that
organization
organization
is
is
using their
using
MS,
their
they are
image.
having their
They are
services
having
on
their
OpenStack.
OpenStack.
They
just
have
to
their
just to
own
they have their own
private cloud.
private cloud. Yeah, we have in Australia. So I remember I did couple of trainings for Telstra on based on OpenStack itself. So they had a 5G too early than us, and that 5G is already working on OpenStack. The organization name is Telstra. Yeah.
Correct, correct. So not only that, you can see the gaming industry, filming industry, financial sectors, healthcare sectors. I'm not sure you're having this knowledge or not, but healthcare sector healthcare sector companies are spending lot of money to build their IT infrastructures. Okay, this is again one more truth, and we know that because we have delivered couple of training programs to few of those organizations. That's why. See, you can see the largest Indian network, railway network is also there in Asia. We are having largest network of railway in India. Also, we are having the one more railway huge network in China. Okay, so you can see its case studies there, China Railways. So they are also having their entire infrastructure on cloud, and especially that cloud which is built with the open source project OpenStack. And this is the list of only OpenStack. Okay, the enterprise grade OpenStack is not here in the list. That list is beyond your imagination. Okay, like Red Hat OpenStack, that those names are not here in this list. They are also having a huge list over there. And also, if you see, there are like more than 15 to 20 organizations are there. They are having their own enterprise OpenStack releases in the market. Okay, so it's the time now to understand what are these components. Okay, what are these components? What are these names? Nova, Glance, Swift, Horizon. So I'm handing over session to Ashutosh sir. Ashutosh sir, please can you explain what are these things?
Yes, I will take it.
Should I
Should
present
I
this?
present this? You can stop screen sharing.
Okay.
I will share. Great. Thank you so much, Pavan, for sharing the detailed info regarding the OpenStack and the use cases. Just to clarify, Pavan was talking about Red Hat, right? Red Hat has their own open source project based on OpenStack, the RPM based operating system, and that project name is RDO project. RDO project. The OpenStack project is specifically for a entire operating system base. You can do it on Ubuntu or any other operating system, what you're looking for. But RDO is exclusive for the RP. SUSE and Red Hat and CentOS can be used, or these OS can be used to deploy their own OpenStack. That is the RDO project. So from OpenStack, Red Hat have this its own RDO project, and from RDO project they have their own downstream project, downstream product called Red Hat OpenStack. So this is how the upstream and downstream works, right? We always clarify that it's like a Bisleri bottle, right? Water which is free, which is upstream, and you get an enterprise bottle which is basically a downstream. Right now, here in OpenStack, three things. One is water. Second is you are putting a purifier. You are putting a like maybe some water purifier at your home. That is RDO project. It's a semi enterprise grade stuff. So people use RDO project based on OpenStack for testing purpose also, right? Now I hope with the one had it is very much clear. Just to clarify one more thing from the Wikipedia, if you see these components are getting increased, right? And these are the number of components. Maybe these are 6 or 7 components, whatever, right? Means these are the collection of, our OpenStack is nothing but a collection of all these components. So if I'm having a latest OpenStack, I have around 38 components. So when you say collection stack, STACK, stack means what? Collection. That's why, and it is open source base 38 services stacks. That's why the name is open plus stack. Are you getting the point? Name is given as a open plus stack. So these are the 38 services. And I remember I had started my OpenStack journey from Grizzly. That's where I started my OpenStack journey, right? And I'm proud to say that because of OpenStack, right, I'm doing something good in AWS also, Azure also, and Google also. Even the day I become a Google authorized trainer, my interview was based on components only. So it's easy, right? So because you're coming from a background where you know in and out of the OSC, even public cloud providers can or maybe using these kind of services in a backend. We don't know, right? So the OpenStack journey or having, as rightly said by Pavan, knowing the OpenStack is highly important. So that is why we hosted this cloud series, that our network, our people should know at least what is OpenStack. And as again rightly said by Pavan, OpenStack is used extensively in 100% telco industries, all 5G. You talk about Nokia, you talk about Vodafone, right? There are some more names we take due to a NDA, due to a non-disclosure agreement. I cannot take few names, but yeah, there are a lot of names involved in the 5G scenarios, right? So all 5G, whatever you are seeing currently is all OpenStack, right? Because of the, of course, in-house capability and security and as well, right? We'll see how it works. So yeah, coming back to my slide. So I usually see in way, how you see it in a mapping way. Even you are learning any cloud technology, it could be a public cloud like a AWS or Google. This diagram will help. So we all know this, right? This is what? A CPU, right? We have HDD, hard disk, SSD, again a disk, then CPU, right? Then motherboard, then we have expansion cards for networking, then RAM, then monitor, right? Then keyboard, mouse, speaker. These are our peripherals of one computer. This makes one computer. Am I right? Now, any cloud has splitted all these services, right? So when I say splitted all these services, how? Let's see. Check. Diagram is changed. Huh? Now, your motherboard is known as, is a component. What motherboard does? What motherboard does in your computer or laptop? Connects everything. Connects all the components. In the same way, OpenStack is having a component called Keystone, which connects all the different component together. Keystone. Then you talk about memory and CPU here. Memory and CPU will be provided called Nova. Nova is a component name. I hope you remember this Wikipedia page, what Pavan was telling. Can you, right? Nova, Glance, Swift, Horizon, Keystone. So these are different components, different aspects, different logical scenarios, right? So if you see this, again, my Nova supports or provides what? RAM and memory, computational power, right? Those who are confused are those who are having knowledge of AWS, you can say this is your EC2. In Google, we name it as a compute engine. Purpose is same, name is different. That's it. Right? Like you wired headphone, it is known as earphone. You get a wireless headphone, you name it as a earbud. Both the same thing is here, right? So technically speaking, they are doing the same thing. Then neutron is there. Neutron as this is what? Networking. Neutron provides networking capacity. So see why these, you might be wondering na, why this is splitted. Let's say I have a scenario where I don't need a networking. So I will not buy these expansion cards. And the billing will happen on the components itself. If you are using less component, you will get less bill. Or maybe you are using one component for a huge time spent, then also you will get a management will be easy, right? So Keystone connects all the component together like motherboard. Nova provides memory and CPU capability. Neutron provides networking capacity. Then comes to a storage. Storage is what? Now storage, object storage and block storage. So in AWS, we name it as a bucket, right? Correct? And then you name it as a volume. Blocks, you create a volume and attach it. No? That is block storage. EBS, we name it as a EBS. Here we name it as a Swift for bucket, object storage, and Cinder for EBS, block storage. Are you getting the point? So this Swift and Cinder is what? Storage. Which storage? Object storage. One is block storage. Right? One more thing, if you go to back with this diagram, one more important thing is there. OS is, do I need an image or OS? Sorry. In AWS, we have AMI, Amazon Machine Image. In OpenStack, Glance provide images. Are you getting the point? Then in see all the things like monitor, we have dashboard. Dashboard is also known as Horizon service. Horizon, HORIZON, Horizon. So Horizon, Glance, Swift, Cinder, Nova, Neutron, Keystone. These are few components. See how many components it has? 7 to 8 components. Around. How many components totally it has? 38. Like that, every component use case is different. And you will be saying a fact that every component is again an individual open source project. Right? Just to give you a simple example of sandwich, you need to put a paneer in a sandwich. You will bring a bread, you will bring a paneer also, na? Or you will in home again. You can do that. That's difficult, right? It's highly difficult nowadays. Are you getting the point? So like that, every component is an open source project. Nova is open source project. Neutron is open source project. Glass source project. Right? And you can map all this with your any cloud provider. It could be AWS or Google or whatever. Make sense? This is how the have a look. Just check the previous slide and this slide. See RAM, expansion card, motherboard, CPU, SSD, HDD, right? Do this. Check. Of course, mouse, keyboard, and speaker are there can be relative stuff, but I don't want to get confused. That's the reason we discussed less. So one more time, let's quickly see. Keystone is it is also known as identity service, identity and authorization. Noah, compute, Neutron, networking, Glance, image, Swift, object storage, Cinder, block storage, Horizon, dashboard. So see, You should understand these naming conventions. Whenever someone say keystone, identity. Whenever someone say Noah, compute. Neutron, networking. Glance, image. Horizon, dashboard. So these are the logical mapping, and these are the project names. Swift क्या है, Cinder क्या है. These all are what? Project name. Open source. Got the point? I hope online people all good till so far. And now this is architecture of OpenStack. All the components, as I said, are connected to identity service. Is identity service here? Can anyone help me? Here. Oh, sorry. Keystone. Then networking service, Neutron. Block storage service, Noah. Image storage, Glance. Object storage, Swift. Dashboard, okay, Orkin telemetry we'll see later. Don't worry. Right? So this is how the logic of something called OpenStack architecture. One thing which is not visible here, all these services generated data, right? So data is stored in a MariaDB or a MySQL, usually MariaDB. In a backend, the database engine is MariaDB. That is also a compulsory component. But it's not front face, it's a backend, right? You want to take this slide, Pavan?
Yes, sir.
Yeah, go ahead. Yes, Pavan, go ahead.
Yes, sir. I was just sharing my screen. So, okay, guys. So, I hope you got the idea behind this. That is, each of the component is having its own work, and then combiningly, we that is what we called it as OpenStack. You can see this diagram here. Maybe the names are not visible for those people who are sitting offline there in the entire hall, but I'll read for you. Don't worry. So, if you see this, there are 9 components here in this diagram. Okay, 9 components are there. So together or collectively, this is what the OpenStack architecture. Now in that, if you look it properly, there is no component called OpenStack here. It's just the collection of different open source project together to achieve some services. Independently also, each of them are having their own what we can say existence. If you ask someone who is doing research in compute, if you ask someone who is doing research in compute, that person need not to install entire OpenStack. That person will completely go for only the Noah project compute service. So he can configure, install and perform everything and do all the research related to the compute services on that only. But when we are looking for any kind of infrastructure solutions or organizational level solutions, so we need multiple services collectively used. Okay, so for that only computing is not needed. No, who will perform that computing activity? Who will decide that? Anyone will come and log in up there and try to access the services. This should not happen. Also, when I say that cloud is there, so most of the time we have means more than 60-70% people are having one idea in their mind. Cloud means only storage, which is not 100% accurate, but which is not 100% false also. But see, storage is one of the important services what cloud is offering. When we say storage services, now in storage also you can have two different types of storages. Mostly, I'll say mostly. Okay, these are block storage services, and some of them also need to have the object storage services. So each of these service is different and there are independent component for that. Then let's say I'm talking about networking. See, in cloud computing, there is nothing going to stand without networking. Nothing can stand without networking. And here we are saying that software defined networks, virtual kind of networks, or virtual network itself, you can say, those we need to offer as a service to someone. Is it kind of a surprising moment for those who are completely beginner in cloud? So see, we are saying that networking services we have to offer to someone. So it's like creating your virtual networks, creating your subnets into that, having route tables to them, setting up some rules in the route table. Okay, these are all networking related services which we have. Means if you have that service, then you will be having virtual Ethernet connections, virtual IP addresses also there, and you know what, that will be having some existence. If you configure it correctly, those IP addresses will be accessible outside the infrastructure of OpenStack as well. So those networking components are there with the help of one service that is called it as a neutron. So you can see here the third component, that is neutron service. So basically, let's do one thing. I hope you got the idea that each of the component is going to provide some kind of services to you. So let's start with this first one, dashboard service. So imagine that our OpenStack is deployed and we want to access that OpenStack services. So suppose we have hosted and we want to access, or maybe our client wants to access, or our team members wants to access. So there is a separate service which will provide a dashboard, means graphical user interface for your OpenStack, and that is called it as a dashboard service. Okay, it is also called it as a horizon. Okay, then if you see the second number here, which is in the left side, that is the identity service. It looks like a lock, right? Those people who have already worked with Amazon or Google Cloud or Azure, you might be aware about one service that is called it as identity access and management. Identity access and management. And what is that? That component will provide you the identity service. So here, keystone name component, keystone name component will provide you the identity. You know what, in the previous diagram Ashutosh sir was saying that it is somehow you can consider that motherboard as a um, that specific service, keystone service. How come? Because that is the service which is actually linking each other. Because if someone wants to access any one of this service, that particular user account or that particular SDK, we have to grant it through the identity service. If identity service is not going to grant that, then that service request will not be processed. So basically, identity service will provide that how many user accounts will be there, which as a user account will have what accesses. There might be team of 10 people, they will have only compute access. Some of means they will be able to only provision instances, cloud virtual machines. Or maybe there are tests at the team of 10 people, they are going to have only access to the object storage. They are going to just upload files over there and they can download those files. Maybe you can maybe like S3 bucket, Amazon S3 bucket, something like that. So each of those user or element can, or soft piece of software can access the compute services or any kind of services only if the identity service is granting the permission. Then one more thing we have to see, that is, if you see the third component here, that is OpenStack networking, which we have just now discussed. That is networking component will be provided to you on demand. That is with the help of the neutron, that is OpenStack networking service. Then let's say fourth component you can see in this diagram, that is block storage service. You know what? This fifth component, compute service, Nova component, which is going to provide you the compute service, will offer you the memory and CPU required for your virtual machine, cloud virtual machine, or instance, you can say. We usually call it as an instance, that is the proper word. So that to that specific instance, you will get the computing and all these computing and memory, CPU and memory, that is the compute from your Nova. But who will provide you the disk for your virtual device, for your virtual machines? You need storage, right? Disk. So that storage disk will be provided by a separate service. There is a separate service called block storage service. Okay, it is called it as a cinder service. With the help of that, we means to the virtual machines, we can have storage disks on demand whenever needed. So can you imagine, for storage, that too only kind of block storage, we are having a separate service there. Then next to that, image storage services there, which is the sixth component. Let's say whenever you want to have any virtual machine on the cloud, means instance, to that instance you can have number of choices of operating systems also. You can have Amazon Linux on your Amazon cloud. You can have any kind of other Linux distributions on every cloud almost, right? Maybe Red Hat Enterprise Linux, maybe CentOS, maybe Oracle Linux, maybe Amazon Linux, maybe Windows kind of service operating systems are there. So there are some, like, let's say Ubuntu with Ansible, then let's say SUSE with Docker. So these kind of operating systems images are pre-configured and stored over there on your OpenStack component. That OpenStack component is image storage service. So you will take virtual machine computing power and all from the Nova, from the compute service, and you will take operating system from the image storage service. So that is going to be the glance. Now with that, what will happen? Your virtual machine will sustain, virtual machine will be there. Now this was about having the virtual machines or having the network, and in that number of virtual machines. But if you see the seventh component here, that is the object storage service. What is object storage service? Sometimes we need cloud service just for file-based servers, file-based storages. Let's say I will be having one Amazon S3 bucket, or relevant services are there in Google Cloud as well as Azure. So there you can just upload the files as object from the browser or maybe from the command line. You can upload it, just like select one file and upload. Whenever you want it, you can download it. You can set restrictions over there, that who can use it, who cannot. Okay. So but this kind of storage service is completely different than that block storage service, because block storage service was giving the storage disk to your instances. Here I am saying that a complete storage service which will be having objects, means files, different types of files you can just upload there and store. And there will be proper indexing, hashing, balancing algorithms will be there. With the help of that, you can manage them. So this kind of service is available in your OpenStack, and that will be with a separate service, separate component, and that is called it as a Swift. Next, you can see here at component, that is telemetry service. Telemetry, metering. See, we are saying cloud services, no? So we must have some record also with us. That what record? That who is using what services, how much services got utilized by whom. In future, suppose you need to have metrics, then this telemetry service will give you the metrics, that who has used what for how much time. In future, if you want to provide billing for that to someone, then this telemetry service will help you to do so. And that's what the celometer is. Celometer means this telemetry service, that service component's name is, the project's name is celometer. This cell service will completely provide you the services for metering these things, that who has used which component, compute, network, block storage, object storage. Okay, if you see that this telemetry service is not connected to identity, it doesn't mean that anyone can do the telemeter. It's like your identity service is most of the time free also. If you're using any public cloud, majority of the time the identity services are free. Okay, so that's why it might be looking outside in majority of the different proprietary clouds also, or let's say public clouds as well. And you can see that ninth component there, that is orchestration service. Orchestration is kind of a functionality you have to what we can say, take a decision and have a control on that. Let's say for example, if I want to use a 10, if I want to use a 10 instances, and if by any chance any one of that instance is getting utilized heavily, the traffic or the utilization of that node is very heavy, it has reached CPU and memory utilization nearly to 100%. So in such cases, we can configure such kind of solutions. With the help of that, it will observe the telemetry services output, cellmeters output, and then depend on that, you can take a decision that what can be the solution on that. You can have one more instance to provision, or you can cut short the resources. So these kind of decisions you can take, and that service is called it as an orchestration service. And that is having an independent name for this service. That service component name is heat. Okay, so dashboard is your user graphical user interface. Then you're having identity service, which is keystone. You have OpenStack networking, that is Neutron. You have block storage service, which is called it as Cinder. You have compute service, which is called it as Nova. You have image storage service, that is Swift. Oh, sorry, my bad. That is Glance. And you have object storage service, that is Swift. You have telemetry services, which is called it as a cellometer, and heat, that is your orchestration service. These are some majorly important, so we can say highly important components that every OpenStack beginner, or what we can say, every beginner should understand, because there are 38 components. We cannot discuss all of them, but these are the nine major components. So I just want to take give this back to Ashutosh sir. Sir Ashutosh, can you go for the next slide and explain this with a summarized way?
Yes. So just to summarize what Pavan has discussed in terms of architecture, we have this slide. So OpenStack has segregated this in these 4 to 5 different scenarios. So very first, if you see the bottom side of this one, that's shared services. So why it is shared? Because these are connected, or these are dependent across the OpenStack. Keystone, then placement, glance, then secrets, that is Barbican. These are the components which needs, or which should be connected to different rest of the components also. Like for example, I need to create a glance. Glance is what? Image. I need to create an image, and now I am in that image, or I am accessing that image. I need a authorization to access that image, right? That authorization will be by my keystone. Keystone provides identity and authorization, like IAM of yours, right? So when I say AWS, identity access management, it is what? Keystone. So that is at a stack level, right? So point is, let's say I want to use a Neutron. That is what? Networking. So when I need to access the networking, initialization policy also, right? That is again done by Keystone. So these are the shared services. That's why they are colored in a different way. Have a look. Then dependent on a project, based on your project, you can use, let's say, compute service. I need a resources. That is Nova. Now, come Nova, we know a container also nowadays. There is another way to deploy the application on container. So there is a service called ZUN, which helps you to deploy what? Containers. Irrespective of Noah, you can use Zoom also. That is, then storage level, we discussed two services already. Which are those? Swift and Swift is at a object storage, Cinder is block storage. We have Manila file system. Manila file system. Manila file system like a EFS. In this, we have EFS, NFS, that is Manila. It uses a NFS Ganesha protocol in a backend. Okay. Anyway, that's a different story. To be very honest, if we start discussing each component, like Pavan was telling, no, we have heat, that is orchestration, and we have celometer. So why you need both? One is, of course, celometer we need it for billing purpose. But it is again a metrics agent. You can achieve the auto scaling feature by using heat plus celometer both together. How? Celometer will give you alarm, saying that your CPU utilization. You launch one instance and the CPU utilization of that instance is more than 80%. It triggers an alarm and it triggers a heat template that will launch one more instance for you. Are you getting the point? So heat celometer can be utilized together also like this. So the point is, yes, these are the logical tools which we use for different purposes. We have workload provisioning. We have Sahara, True, Magnum. At this point, I need to tell you one more logical stuff. We had not discussed how you deploy OpenStack, how you install OpenStack. OpenStack can be using different tools like Ansible, which is a Cola Ansible, OpenStack Charms, Hello, then Bifrost, and OpenStack Helm. Then you can even use a Packstack. Then you can use a Puppet. Different option is there to deploy OpenStack. One common option is triple O. Triple O is OpenStack on OpenStack. OpenStack on OpenStack means deploy one OpenStack which deploys number of OpenStacks. That is known as triple O, right? So anyway, it has its own component. So these Pro, Sahara, Magnum, these are related to workload provisioning in that case, right? So technically speaking, there are more for triple O also. Like there is a, for example, component is Ionic. Ionic is a component which does provisioning for triple O. So this is not a triple O discussion, please understand. This is still only what? OpenStack discussion. But to deploy OpenStack, another OpenStack, which is triple O. This is a project of HP. HP has started this triple O project and then later on it becomes open source. Right? In that you can do a workload provisioning like this. Application lifecycle, you can use these components, and for orchestration, you can use these components. So see, in this slide, you can see more components and segregation also. And for web front end, what? Horizon and ECD. Right? So in a nutshell, you can bifurcate the components like this. Have a look. So when you say storage, I have now block storage, object storage, and file system storage. That is Manila. Manila file system, which is Ganesha protocol, which is NFS, EFS. In AWS, it is also known as EFS. So yeah, this is what the logic of stack components in an extended manner, in a little bit extended manner, right? Yeah. So from this slide onwards, we had discussed the individual component again, right? Before that, Pavan, you need, do you say something or do you need to add anything in my discussion?
No, sir. Just one point to add. That is, guys, whenever OpenStack is deployed in any infra, no. So we have actually three ways to access that. That is, one is with the help of your browser, okay, which is going to be through the Horizon. Okay, then we do have one more option that you can access it with the help of CLI. There are proper OpenStack commands. With the help of that, you can manage your OpenStack architect infrastructure. And one more option is there, that is using APIs. Okay, so if you are able, you can build your own small piece of software, and through that you can access your OpenStack components. That is the API services you can use. So basically, I hope everyone is there thinking towards OpenStack in this particular session, being a part of the organization who wants to provide services to someone else. Okay, let's not be on the part of only the user part. Okay, so if you think like a provider, then it will be more interesting and more easy to understand. Yes, sir, over to you.
Yeah, just to clarify, because I know there might be a just to clarify triple O OpenStack, I have one image to share so that you will understand how things works in a triple O architecture. 1 minute. Sorry, it's not OpenStack. For the images, I know my screen is not shared on the. So sorry, just a second. This is little off context. That's why I don't have in a slide. So please excuse me for that. But yeah, this slide will explain all the logical component. Check. This is what I was talking about. On a left hand side, you will see something called undercloud. Can you see that? And one is some overcloud. Overcloud is our OpenStack which we are using. Undercloud helps overcloud to deploy. Now you will all these things. No? Why things are making why we are making things complicated, right? The point is, in a private organization, we need number of different OpenStack clusters. Let's say I need 5 OpenStack clusters. Then what I will do? I will use undercloud to dip OpenStack cluster. Easy, no? It's easy, right? It's like you're creating a robot, and that robot later on creating the diff another robots. I think there was one film, no? It happens in that film. We all know that film, right? Let's not talk about that. Right? So like that, undercloud and overcloud. So undercloud is used to deploy overcloud, right? So in an undercloud, there are again components, Mistral, again Keystone is there, Horizon is there, Horizon, sorry, Ionic. Can you see this? Ionic is there. Then some components are common and some are new. This undercloud and overcloud logic, right? So that's what the logical scenario undercloud and overcloud is. So yeah, nothing else. So coming back to the component discussion, these are a couple of slides in which we are basically discussing components one more time, nothing else, right? So Noah, we all know Noah is a Noah is the OpenStack project again. That provisioner compute service or instance, that is also known as virtual servers or virtual machines or instances, whatever. Creating VMs, bare metal servers. I hope now you got my point why I showed you the under cloud and over cloud slide. Can you see here? Servers through use of Ionic. Ionic is a component which does bare metal provisioning and it is on under cloud, not on over cloud, right? And has limited support anyway. Nova runs as a set of daemon on top of existing Linux server. That's okay. Now, one more thing. So sorry, I'm going back to this slide one more time. In this slide, we have 9 components around, right? Now, how you deploy these 9 components? This how you create an OpenStack server. Let's say my organization asks me, "Hey, Ashutosh, we need to deploy our private cloud." What I will? There are a couple of ways. One is buy a huge configured server and deploy all the components on one bare metal. All components will one single machine. That is one. Or do multi-host. You might have 3 to 4 hardwares, different machines. Connect all them together and deploy. One will have compute service running. One will have only Cinder running. One will have only Swift running, or like that. That is also possible. This is how you do the deployment. Multi-node or single node. The deployment of OpenStack can be achieved. Okay. You just need to tell when you do under cloud when you do over cloud provisioning, you have to tell the IP address of it. That's it. That's how the under cloud and over cloud works. So yeah, Nova. Coming back to the slide, 1 minute. Hope I'm clear with the Nova. Then we have something called Zune. Now, interesting part, the left-hand side is the logo or icon of technologies, open source technologies. So that Dolphin is basically a Zune, is an OpenStack container service, right? Swift is distributed object storage. It is also known as blob storage, right? The advantage of Swift is it creates a replica of your data by default, and it is cheaper also. We all know in AWS also, object storage is cheaper than EBS block, right? Then Cinder. Cinder is basically the OpenStack providing a volume. No VMs, right? Or bare metal, whatever. So this is known as Cinder, block storage, right? Manila is an OpenStack shared file system providing a shared file systems as a service. File system as a service, right? Maybe second last slide. Neutron. Neutron is basically OpenStack project to provide network connectivity, right? By the way, in Glance, I just need to add, when you say Glance, we are creating the images, right? We are storing the, what happened? Slide, 1 minute, some delay looks like. Oh, Glance is here, no problem. I thought Glance, my bad. So Neutron, networking, we all know, right? Then Octavia. Now this is again an interesting scenario. Octavia, this component we didn't discuss as of now. This load balancer as a service, LBAAS. We have load balancer in AWS also, na? That is Octavia. Getting the point? Octavia. It is a L2 level load balancer. Then we have something called Glance, right? It is a service which is providing our images. Now, this image can be a QCOW2 format, VMDK format, right? VDI format, can be any format, ISO format. Even this can be a container also, container image also. That is the purpose of Glance. Keystone, we all know. Keystone is basically a identity service which does authorization and authentication of our entire OpenStack, right? That's what the keystone is. I think that's yeah, that's all from the OpenStack. That's how the OpenStack entire architecture works.